Learning objectives. In this chapter, the user would learn the following in detail. Format of test cases, DU, DC and other data paths, test data selection, branch coverage, statement coverage, precondition and postcondition, test schedule and checkpointing, creating test cases. Branch coverage. Coverage is a metric, percentage of these paths exercised by a test suite. Commercial tools frequently contain coverage analyzers. Code coverage model calls out the parts of an implementation that must be exercised to satisfy an implementation-based test model. Coverage reports can point out inadequate test suites, suggest the presence of surprises such as blind spots in the test design, help identify parts of the implementation that require implementation-based test design. TEX and AWK are widely used programs with comprehensive test suites. How to measure coverage? The source code is instrumented. Depending on the code coverage model, code that writes to a trace file is inserted in every branch, statement, etc. Most commercial tools are used to measure segment and branch coverage. Control flow graphs. A segment is a node in the CFG. A conditional transfer of control is a branch represented by an edge. An entry node represents the entry point to a method. An exit node represents an exit point of a method. Code coverage models. Statement coverage, branch coverage, multiple condition coverage, object code coverage, data flow coverage. Branch coverage or edge coverage. Branch coverage requires that each branch will have been traversed and that every program entry point will have been taken at least once. Branch coverage tells us how many of the possible paths that has been tested. C branch equals percentage of branches tested. Write test cases that cover all branches of predicate nodes. True and false branches of each if the two branches corresponding to the condition of a loop, all alternatives in a switch statement. In modern language, branch coverage implies statement coverage. Example for branch coverage. Test case 1 follows path 1 to exit. Test case 2, 1, 2, 3, 4, 5, 7, 8, 2, 3, 4, 5, 7, 8, 2, exit. To achieve it, pick a set of start to end paths in the CFG that cover all branches. Consider the current set of chosen paths. Try to add a new path that covers at least one edge that is not covered by the current paths. Then write test cases to execute these paths. Achieved when every path from a node is executed at least once. At least one true and one false evaluation for each predicate. Can be achieved with D+1 paths in a control flow graph with D nodes. Here, nodes are two-way branching and no loops. Creating test cases. Writing better test cases. Requirement IDs being covered in the test case. Test conditions and expected results being exercised in the test case. Initial setup required for executing the test script. This could be environment or data or configuration setup to be done before running the test case. Post-execution activities. For example, delete the application user web admin after test execution is completed. Priority, high, medium and low of the test case. Priority will help the tester to decide which test cases have to be run earlier than others. Complexity of the test case. It will help to identify and filter test cases based on complexity. This would help in assigning test cases to testers before test execution. Approximate time required for executing the test case. This entry is required from project management perspective to track the productivity and also to ensure we can still meet the test execution deadlines. Test steps. This contains instruction on what actions to perform and what test data to use. Expected results. Each test step will have a corresponding expected result field that would specify the expected response. Actual result. Each test step will have a corresponding actual result field. Tester would enter the details on the response he saw after executing the test step. Test step result. Typically, this field would contain values not applicable no run, passed, failed, or in progress, etc. Test case version number, test case creation timestamp, revision history, when and who wrote or modified the test case, etc. Test case status, draft, completed, reviewed, not valid, etc. Test case execution timestamps, associated defects. This field will help to identify what are the existing defects that are associated with a test case. Project name, application name. How to write test cases. Write test cases based on requirements, use cases, design documents. Understanding requirements. First, understand business requirements to get the big picture of what is being achieved from business perspective. Read and understand how business requirements are exploded into functional requirements. Go through technical specification and UI design document to gain understanding of how the business requirements get translated into application functionality. Once you do this exercise, obviously you will get at least a few questions, or you may even discover a few gaps in the requirements. Reach out to business analyst and business user as required and get your questions answered. Now you are ready to go ahead with your test scenario identification. Identify test scenarios, test conditions, and expected results. Once you have a sign-off on test scenarios, test conditions, and expected results, start creating test cases. Design document. Also consider verifying the technical aspects mentioned in the technical and look and feel aspects mentioned in the UI design documents. Some of the technical aspects like field length, validation, data structures will be documented in detail in technical specification. So during test case construction, we have to incorporate additional validations as well. Write test cases. Get the test cases reviewed, detail of each test case, write test cases in plain English, requirement traceability metrics, provide test data within the test cases, test case version control, prioritize test cases, prerequisites and cleanup sections. Test case review. Get your test cases reviewed by business analysts and business users. It is better to get review comments from business analysts and business users before testing starts rather than they pointing out at deficiencies of your test cases during acceptance testing or post-implementation. How detailed should be a test case? Test case steps should be as detailed as possible and should not be written at high level. Writing detailed test steps is very important, considering the fact that the same person who wrote the test cases may not always execute the same test cases. If the test cases are not very detailed, then the person who executes a test case for the first time will not be able to validate the system thoroughly, as he or she might not have gone through the requirements and will test only as per the test case steps. Example of detail. Example of a test case that is written at high level. Step 1. Step description. Login to test application with valid user ID, password. Expected result. Home page is displayed. Step 2. Step description. Click logout link on home page. Expected result. Login page is displayed. Example of a test case that is written in detail. Step 1. Step description. Open URL https://www.example.com/login.asp. Expected result. Login page is displayed and contains the below fields. Username text field, password text field, submit button. Step 2. Step description. Once login page is displayed, enter valid user ID password. Enter user 1 in username text field. Enter ABC123 in password text field. Expected result. Verify username is populated with the text user 1. Verify text entered in password field is masked and is not readable. Step 3. Step description. Click submit button. Expected result. Verify application home page is displayed. Verify home page displays welcome user 1 message on top of left navigation menu. Verify left navigation menu contains links, directory, submission, latest links, approved links, logout. Step 4. Step description. Click logout link on the left menu. Expected result. Verify user is successfully logged out of the application and application login page is displayed https://www.example.com/login.asp. Requirements Traceability Matrix (RTM). The Requirements Traceability Matrix is a document that links requirements throughout the validation process. The purpose of the Requirements Traceability Matrix is to ensure that all requirements defined for a system are tested in the test protocols. Test case prioritization. For each test case, determine RE using business value defect criticality, defect-prone components, and developers. Risk exposure RE equals size of loss into probability of loss. Loss, the value lost if the risk occurs. Probability, the chance of the risk to occur. Example, size of loss 20 person-hours, probability of loss 20%. RE equals 20 into 20%, 4. Maximizing the value gained in testing by reducing risk associated with tests and maximizing risk reduction leverage, RRL. Greedy approach. Prioritize test cases based on RRL, focusing on tests with high RRL first. RRL equals RE before minus RE after divided by cost. Cost can be the effort spent for testing. RE before, RE after, risk exposure before and after testing. Why do we write test cases? Test cases are supposed to be part of the deliverable to the customer. Test cases are for team internal use only, typically system-level testing. Testing efficiency should be the goal in this case. The idea is to write test cases based on design while code is incomplete so that we could test product quickly once the code is ready. Test cases are dramatically reworked during test execution. Creating test cases. Create a test script by recording using automation tool. Create test script in Selenium IDE using the most common method by recording. Afterward, we shall execute our script using the playback feature. Step 1. Launch Firefox and Selenium IDE. Type the base URL http://newtours.dmout.com/. Toggle the record button on if it is not yet toggled on by default. Step 2. In Firefox, navigate to http://newtours.dmout.com. Firefox redirects the page similar to the one shown below. Step 3. Right-click on any blank space within the page, like on the Mercury Tours logo on the upper left corner. This will bring up the Selenium IDE context menu. Note, do not click on any hyperlinked objects or images. Select the Show Available Commands option. Then select Assert Title Exact, Welcome Mercury Tours. This is a command that makes sure that the page title is correct. After clicking on the Assert Title Context menu option, your Selenium IDE editor pane should now contain the following commands. Step 4. In the username text box of Mercury Tours, type an invalid username, invalid UN. In the password textbook, type an invalid password, invalid PW. Your editor should now look like this. Step 5. Click on the Sign In button. Firefox redirects to the below page. Step 6. Toggle the record button off to stop recording. The script now looks like the one shown below. Step 7. Now that we are done with our test script, we shall save it in a test case. In the File menu, select Save Test Case. Alternatively, you can simply press Ctrl+S. Step 8. Choose your desired location and then name the test case as invalid_login. Click the Save button. Step 9. Notice that the file was saved as HTML. Step 10. Go back to Selenium IDE and click the Playback button to execute the whole script. Selenium IDE should be able to replicate everything flawlessly. Create a script manually with Firebug using Selenium IDE. Step 1. Open Firefox and Selenium IDE. Type the base URL http://newtours.dmout.com. The record button should be off. Step 2. Click on the topmost blank line in the editor. Type open in the command text box and press enter. Step 3. Navigate Firefox to our base URL and activate Firebug. In the Selenium IDE editor pane, select the second line, the line below the open command, and create the second command by typing assert title on the command box. Feel free to use the autocomplete feature. Step 4. In Firebug, expand the head tag to display the title tag. Click on the value of the title tag, which is Welcome Mercury Tours, and paste it on the target field in the editor. Step 5. To create the third command, click on the third blank line in the editor and key in type on the command text box. In Firebug, click on the username text box. Notice that Firebug automatically shows you the HTML code for that element. Step 6. Notice that the username text box does not have an ID, but it has a name attribute. We shall therefore use its name as a locator. Copy the name value and paste it on the target field in Selenium IDE. Still in the target text box, prefix username with name equals to, indicating that Selenium IDE should target an element whose name attribute is username. Type invalid UN in the value text box of Selenium IDE. Your test script should now look like the image below. We are done with the third command. Note, instead of invalid UN, you may enter any other text string. But Selenium IDE is case sensitive and you type values attributes exactly like in the application. Step 7. To create the fourth command, key in type on the command text box. Again, use Firebug's inspect button to get the locator for the password text box. Paste the name attribute password onto the target field and prefix it with name equals to. Type invalid PW in the value field in Selenium IDE. Your test script should now look like the image below. Step 8. For the fifth command, type click and wait on the command text box in Selenium IDE. Use Firebug's inspect button to get the locator for the sign in button. Paste the value of the name attribute login onto the target text box and prefix it with name equal to. Your test script should now look like the image below. Step 9. Now that we are done with our test script, we shall save it in a test case. In the File menu, select the Save Test Case. Alternatively, you can simply press Ctrl+S. Step 10. Choose your desired location and then name the test case as invalid_login. Click the Save button. Step 11. Notice that the file was saved as HTML. Create test cases using QTP. It is a commercial tool and trial version can be downloaded from HP's site directly. Only the current version, which is Unified Functional Testing 11.5 version, is available for download. Record and playback. Recording a test corresponds to recording the user actions of the application under test so that UFT automatically generates the scripts that can be played back. Record and playback can give us the first impression if the tool can support the technology or not, if the initial settings are done correctly. Steps for record and playback are as follows. Step 1. Click on New Test from the start pages as shown below. Step 2. Upon clicking New Link, the new test window opens and the user needs to select the test type. Select GUI test, give a name for the test and also the location where it needs to be saved. Step 3. Once a new test is created, the new test screen opens as shown below. Click on Action 1 tab, which is created with Action 1 by default. Step 4. Click on Record menu and select Record and Run settings as shown below. Step 5. The Record and Run settings dialog opens and based on the type of application, one can select Web, Java, Windows applications. For example, we will record a web-based application, http://easycalculation.com. Step 6. Click Record button. The Internet Explorer opens automatically with the web address http://easycalculation.com as per the settings. Click Numbers link under Algebra and key in a number and hit Calculate. Upon completion of the action, click Stop button in the record panel. You will notice that the script is generated as shown below. Step 7. Now play back the script by clicking on the Playback button. The script replays and the result is displayed. Step 8. The result window is opened by default, which exactly shows a timestamp of execution, pass and failed steps. Format of test cases. What is test case? Test cases are written based on business and technical requirements, use cases and technical design documents. A test case contains a sequence of steps describing actions to be performed, test data to be used, an expected response for each action performed. There can be 1:1 or 1:n or n:1 or n:n relationship between requirements and test cases. The level of detail specified in test cases will vary depending on organizations, projects, and also on the test case template used or on the test management tool being used in the project. A test case has components that describes an input, action, and an expected response to determine if a feature of an application is working correctly. Construction of test cases also helps in finding issues or gaps in the requirements, technical design itself. As test case construction activity would make tester to think through different possible positive and negative scenarios. It is test cases against which tester will verify the application is working as expected. Number of test cases to be created depends on the size, complexity, and type of testing being performed. Documented test cases are referred to as test scripts. Related test cases or test scripts are collectively referred to as a test suite. Test case examples. Test case for ATM. TC1, successful card insertion. TC2, unsuccessful operation due to wrong angle card insertion. TC3, unsuccessful operation due to invalid account card. TC4, successful entry of PIN number. TC5, unsuccessful operation due to wrong PIN number entered 3 times. TC6, successful selection of language. TC7, successful selection of account type. TC8, unsuccessful operation due to wrong account type selected with reference to that inserted card. TC9, successful selection of withdrawal option. TC10, successful selection of amount. TC11, unsuccessful operation due to wrong denominations. TC12, successful withdrawal option. TC13, unsuccessful withdrawal operation due to amount greater than possible balance. TC14, unsuccessful due to lack of amount in ATM. TC15, undue to amount greater than the day limit. TC16, undue to server down. TC17, undue to click cancel after insert card. TC18, undue to click cancel after insert card and PIN number. TC19, undue to click cancel after language selection, account type selection, withdrawal selection, enter amount. Test cases for a web page. Test it only with username. Test it only with password. Username with wrong password. Password with wrong username. Right username and right password. Cancel after entering username and password. After long username and password that exceeds the set limit of characters. Try copy-paste in the password text box. After successful sign-out, try back operation from your browser. Check whether it gets you to the signed-in page. Why do we write test cases? It is used to validate the testing coverage of the application. Writing test cases brings some sort of standardization and minimizes the ad hoc approach in testing. How to write test cases? Here is a simple test case format. Fields in test cases. Test case ID. Unit to test what is to be verified. Assumptions. Test data, variables and their values. Steps to be executed. Expected result. Actual result. Pass, fail. Comments. Basic format of test case statement. Verify using tool name, tag name, dialog, etc. With conditions. 2. What is returned, shown, demonstrated. Verify used as the first word of the test case statement. Using to identify what is being tested. You can use entering or selecting here instead of using, depending on the situation. For any application, basically you will cover all the types of test cases, including functional, negative, and boundary value test cases. All test cases should be simple and easy to understand. Test cases should be given as points, not like essays. Sample test cases for manual testing. What are preconditions and postconditions? Precondition is presetting that tester needs to run that test case. Precondition is a predicate. It can hold before a function executes. For example, a registered user needs to activate by administrator from backend before he or she uses his or her account. So when tester will write test cases for login, then he or she will mention it in precondition, user has activated by administrator. Precondition is always written with perfect tense. Postcondition is a predicate known to hold after a function executes, whenever the precondition also holds. Postconditions are sometimes tested using assertions within the code itself. Often, postconditions are simply included in the documentation of the affected section of code. Example 1. The result of factorial is always an integer and greater than or equal to 1. So a program that calculates a factorial of an input number would have postconditions that the result after the calculation be an integer and that it be greater than or equal to 1. Example 2. If we write test case for login page, there is precondition, prerequisite. SW should be installed on system, login page should be available on desktop. Postcondition, login successful. Written in the programming language itself. Full pre and post conditions may be more complex than the code, but useful even if they do not cover every situation. The precondition for binary trees. Checks. The root may be null. Return false. All nodes are unique. No cycles. Every node has one parent except the root. An example may be seen on the screen. Using pre and post conditions. Pre-post conditions are specifications. To perform a test, check that the test input satisfies precondition. Run test, check that the test result satisfies post condition. It doesn't help to write tests, but it helps to run them. That means we must use the precondition to guide the generation of tests. The technique: instrument the precondition, add code to observe its actions. In particular, record fields of the input the precondition accesses. Observation: if the precondition does not access a field, then the result of the precondition did not depend on that field. A simple algorithm. User selects maximum input size k, generate all possible inputs up to size k. Discard inputs where precondition is false, run program on remaining predicates. Check the results using the post condition. Statement coverage. Statement coverage, node coverage. It requires that each statement will have been executed at least once. Simplest form of logic coverage. Need to write test cases that cover all nodes in the control flow graph. This is the simplest coverage measure. CStat equals percentage of statements tested. Example: suppose that we write and execute two test cases. Test case 1 follows path 1, 2, exit. That is, we never take the loop. Test case 2, 1, 2, 3, 4, 5, 7, 8, 2, 3, 4, 5, 7, 8, 2, exit. Loop twice and both times take the true branch. Control flow graph. Paths in our example. Entry-exit path is a path from the entry node to the exit node. Path expressions represent paths as sequence of nodes. Loops are represented as segments within parentheses followed by an asterisk. Achieved when all statements in a method have been executed at least once. Segment coverage counts segments rather than statements. Assume two segments P and Q. P has one statement, Q has 9. Exercising only one of the segments will give 10% or 90% statement coverage. Segment coverage will be 50% in both cases. Statement coverage issues. Predicate may be tested for only one value, misses many bugs. Loop bodies may only be iterated once. Statement coverage can be achieved without branch coverage. Important cases may be missed. Test data selection. Test data. Any such specifically identified data which is used in tests of software system. In order to test a software application, you need to enter some data for testing. Test data in Excel sheet which can be entered manually while executing test cases, or it can be read automatically from files, XML, flat files, database, etc., by automation tools. Test data is used to confirm the expected result. When test data is entered, the expected result should come, and some test data is used to verify the software behavior to invalid input data. Test data is generated by testers or by automation tools which support testing. Most of the times in regression testing, the test data is reused. It is always a good practice to verify the test data before reusing it in any kind of test. Preparing proper test data is part of the test setup. Generally, testers call it as a test bed preparation. In test bed, all software and hardware requirements are set using predefined data values. Systematic approach for building test data while writing and executing test cases. Otherwise, there are chances of missing some important test cases. Tester cannot justify any bug saying that the test data was not available or was incomplete. It is every tester's responsibility to create his or her own test data according to testing needs. Do not even rely on the test data created by other tester or standard production test data which might not have been updated for months. Always create fresh set of your own test data according to your test needs. Sometimes it is not possible to create complete new set of test data for each and every build. In such cases, you can use standard production data. But remember to add or insert your own data sets in this available database. One good way to design test data is use the existing sample test data or test bed and append your new test case data each time you get some module for testing. This way you can build a comprehensive data set. Test data set examples. No data. Run your test cases on blank or default data. See if proper error messages are generated. Valid data set. Create it to check if application is functioning as per requirements and valid input data is properly saved in database or files. Invalid data set. Prepare invalid data set to check application behavior for negative values, alphanumeric string inputs. Illegal data format. Make one dataset of illegal data format. System should not accept data in invalid or illegal format. Also check proper error messages generated. Boundary condition dataset. Dataset containing out-of-range data. Identify application boundary cases and prepare dataset that will cover lower as well as upper boundary conditions. Dataset for performance, load and stress testing. This dataset should be large in volume. By this way, creating separate test datasets for each test condition will ensure complete test coverage. What is test data preparation tools in software testing? Test data preparation tool is useful when an extensive range of volume or data is needed for testing. They are very useful for performance and reliability testing, where a large number of realistic data is needed. They may be used by developers and may also be used during system or acceptance testing. Test data preparation tools allow data to be selected from an existing database or created, generated, manipulated, and edited for use in tests. The most sophisticated tools can deal with a range of files and database formats. Features or characteristics of test data preparation tools are as follows: to extract selected data records from files or databases, to massage data records to make them anonymous or not able to be identified with real people for data protection, to enable records to be sorted or arranged in a different order, to generate new records populated with pseudo-random data or data set up according to some guidelines, that is, an operational profile, to construct a large number of similar records from a template, for example, to give a large set of records for volume tests. Testing schedule. An object for planning the scope and frequency of the stability tests. The testing schedule specifies what will be tested, storage conditions, when the stability test will take place, testing dates, how the test will be performed. Test schedule includes the testing steps or tasks, the target start and end dates, and responsibilities. It should also describe how the test will be reviewed, tracked, and approved. Use. Create a testing schedule for a stability study in which you intend to test the storage conditions in predefined intervals. This testing schedule is explicitly assigned to the stability study for which it is intended and cannot be assigned to any other study. Create the testing schedule by means of a follow-up function in the stability study. The system then automatically creates a new item in the testing schedule for each storage condition specified in the stability study. In the testing schedule, assign an inspection plan to each storage condition. Structure. A testing schedule consists of the following elements. Testing schedule header. The header primarily contains scheduling information from the maintenance strategy, which must be assigned to the testing schedule when you created it. This information includes the time-based testing frequencies and the various scheduling parameters. The assignment of the strategy to the header simply informs the system which intervals will be available for use in this particular testing schedule. Assign the individual intervals to the various storage conditions at the item level of the testing schedule. Testing schedule items. The system automatically creates an item in the testing schedule for each storage condition in the stability study. This normally occurs automatically when you create the testing schedule by means of a follow-up function in the stability study. The object entered for testing schedule item is the physical sample that is associated with the storage condition in this stability study. If specific additional storage conditions in the stability study after the testing schedule has been created, you must manually create the items for these additional storage conditions in the testing schedule. For each physical sample associated with the storage condition, you must maintain the following data for the testing schedule item. The inspection type with which the inspection lots for the storage condition are to be created. This inspection type must be assigned to inspection lot origin 16 in customizing for quality management by choosing quality inspection. Inspection lot creation maintain inspection lot origins and assign inspection types. The inspection plan according to which the storage condition will be inspected. Assign an inspection plan to a storage condition that contains the same strategy as the one specified in the testing schedule. The frequencies you select from the strategy and assign to the operation level of the inspection plan determines the dates when this operation will be tested. For example, you may have maintained an operation in such a way that it will be tested only once after 3 months for a particular storage condition. The system determines the dates when a storage condition will be tested and the types of tests to be performed for a storage condition after you have assigned an inspection plan. Integration. The testing schedule is a special type of maintenance plan. A testing schedule is always a time-based strategy plan with a maintenance plan category that supports physical samples as a reference object and inspection lots as scheduling call objects. In standard systems, the maintenance plan category is provided as a testing schedule category. Use this testing schedule as a copy model if you want to define your own testing schedule types in QM customizing for stability study. Deadline monitoring. The calculation of the test dates for the testing schedule occurs automatically when you define the start date for the stability study using a follow-up function in the study. On the basis of this date, the system first calculates all of the test dates for the entire duration of the study. The creation of call objects for a specific date occurs at a later time, either on the planned date or at an earlier date based on a user-specific lead time generated by a periodically running batch job. For each storage condition to be tested on this date, the system creates an inspection lot with the physical sample for the storage condition and the exact inspection operations from the inspection plans that have been planned for this date. Example: checkpointing. What is checkpoint? A checkpoint is a verification point that compares the current value with the expected values for specified properties of an object. If current and expected value match, it generates a pass status, otherwise fail status. A single checkpoint replaces a number of test steps or script statements that perform the same comparison. Types of checkpoints. Standard checkpoints compares the expected values of object properties captured during recording to the current values of object during a run session. Page checkpoint is a standard checkpoint created for a web page and can be called a page checkpoint. It is used to check total number of links and images on a web page. Page checkpoints can also be used to check load time, time taken to load a web page. Bitmap checkpoint helps a user in checking the bitmap of an image or a full web page. It does the pixel-by-pixel comparison between actual and expected images. Image checkpoint enables you to check properties like source file location of a web image. Unlike bitmap checkpoint, you cannot check pixels, bitmaps, using image checkpoint. Text checkpoint is used to check expected text in a web page or application. This text could be from a specific region of the application or a small portion of text displayed. Accessibility checkpoints verifies compliance with World Wide Web Consortium W3C instructions and guidelines for web-based technology and information systems. These guidelines make it easy for disabled to access the web. Database checkpoints creates a query during record time and database values are stored as expected values. Same query is executed during runtime and actual and expected values are compared. Table checkpoint can check the contents of cells of a table grid appearing in your environment. You can also check various table properties like row height, cell width, and so on. Table checkpoint is similar to database checkpoint. XML checkpoints used to verify XML data, XML schema, etc. Example: QTP checkpoints. QTP is an automation tool. QTP Quick Test Professional. Quick Test adds a checkpoint to the current row in the keyboard view and adds a checkpoint statement in the expert view. By default, the checkpoint name receives the name of the test object on which the checkpoint is being performed. We can choose to specify a different name for the checkpoint or accept the default name. When we run the test, Quick Test compares the expected results of the checkpoint to the current results. If the results do not match, the checkpoint fails. We can view the results of the checkpoint in the test results window. We can also use the check property method and the check item property method to check specific property or item property values. Inserting checkpoint not in the recording mode. When the user wants to insert a checkpoint, one has to ensure that most of the checkpoints are supported during the recording sessions only. Once the user stops recording, checkpoints are not enabled. Below figure shows the checkpoint menu when the user is not in the recording mode. Adding checkpoints during recording. We can add checkpoints during a recording session or while editing your test. It is generally more convenient to define checkpoints after recording the initial test. To add checkpoints while recording or editing, use the commands in the Insert Checkpoint menu or click the Insert Checkpoint button on the toolbar. This displays a menu of checkpoint options that are relevant to the selected step. To add a checkpoint while editing, right-click the step where you want to add the checkpoint and choose Insert Standard Checkpoint. Select the step where you want to add the checkpoint and choose Design Checkpoint Standard Checkpoint. Right-click any object in the active screen and choose the relevant checkpoint option. Insert Standard Checkpoint, Insert Bitmap Checkpoint, Insert Accessibility Checkpoint. Steps to insert Standard Checkpoint in QTP. It is used to check the object property value, compares the expected value with the actual value during runtime. It can be set during recording or editing a test. Active screen can also be used to insert this checkpoint. It is important that sufficient information be available in the active screen to insert a checkpoint. For example, if there is a screen with Login Edit Box, Password Edit Box, OK, Cancel and Help buttons, we need to check if the Cancel button is visible. We are trying to achieve this by placing a checkpoint on the visible object property of the Cancel button. While recording can be performed after login, enter password and click OK. And the setting on the active screen is just to store the objects. Not be able to place a checkpoint on the Cancel button because the active screen does not possess information about that object. Therefore, it is important for the active screen to have captured all the objects in the page, and only then we can insert the checkpoint. Once added, the checkpoint properties can be changed using the Checkpoint Property dialog box. Every checkpoint gets added to the local object repository when added. It can be moved to the shared object repository if needed. Supported for all the environments as long as the appropriate add-ins are loaded. Some examples of the objects that this can be used on are web images, edit boxes, static text, web tables, etc. How to insert a standard checkpoint while recording. Step 1. Insert Checkpoint. Select this option from the menu after starting a record session. Step 2. Standard Checkpoint icon. Clicking on this icon also results in the same thing. Step 3. A list of relevant checkpoints applicable to the current or selected step on performing one of the steps listed in 1 and 2. Step 4. Select the type of checkpoint. We will select standard in our case. Step 5. QTP interface gets hidden and the user can choose the object in the AUT over which the user wants to insert a checkpoint. Step 6. Select the object and the following screen appears. Step 7. Choose the object and click OK in the dialog. The Checkpoint Properties dialog box is displayed. Step 8. Select the properties you want checked and click OK. We are going to choose just the name. As you can see above, you can modify the properties to either a constant value or parameterize. There is also a timeout parameter that you can set. What this means is that QTP waits for that particular number of seconds specified in this dialog for a certain object to attain a property value before it performs the check. Step 9. This is how we set the parameters and click OK. Step 10. This is how the checkpoint looks in the keyboard view. Step 11. In the expert view, the following code gets displayed. Browser, Gmail, email from Google, page, Gmail, email from Google, web button, sign in, checkpoint, sign in _2. Conclusion. In this chapter, we have covered the following in detail. Format of test cases, DU, DC and other data paths, test data selection, branch coverage, statement coverage, precondition and postcondition, test schedule and checkpointing, creating test cases.